What's up, 7th grade? Mr. Agnos here, and in this video I'm going to give you some homework help on homeworks 7-2K and 7-2G. A lot of new stuff got thrown at you. So I'm going to go through the homework here and do some examples, point out, give you some tips and some hints. Again, this video isn't meant to be totally comprehensive, meaning you're going to know everything after this video. It's just meant to get a spark going, right? Guide you in the right direction. It's really important that you're asking questions in class, right? So that we can go over problems together, and you can get all your specific questions answered. All right, I'm gonna go ahead and start with number 2. It says factor the algebraic expression, and they give me 16a plus 10. All right, an algebraic expression is a mathematical sentence like this that contains numbers and variables, and when we say that we're going to factor it, we're going to basically do the distributive property in reverse. So I'm going to look at my two terms here. My first term is 16a, and my second term is 10. And I'm going to see, well, what factors do they have in common? A factor is a number that divides evenly, right, into each of these. So 16 has 1, and we don't count 1. Actually, we don't count 1 because 1 divides evenly into everything. So 16, we have 2, 4, 8, and 16. And for 10, I have 2, 5, and 10. And so you can see that the only factor that they have in common is 2. Okay? So what I'm going to do is I'm going to factor out the 2. So it's almost like I'm doing my arrows in reverse, right? I'm going to pull out a 2, and then I put some parentheses here, and I say, okay, 2 times what will give me 16a. So the easiest way to think about it is 2 times what will give me 16? 8. And then we're talking a's, right? So 2 times 8a, if I have a pile of 8 a's, and then I have 2 of those, well, now I have 16 a's, right? Plus 2 times what gets me to 10? Well, that would be 5. So this is the factored form, right? This is the factored form. It's an equivalent mathematical sentence. That means it has the same value. It means the same thing as this one, but this is in factored form. And you can see that last week, if I would have given you this, and said, hey, use the distributive property, you would have said 2 times 8a is 16a plus 2 times 5 is 10. And we're right back where we started, right? It's kind of like we create a circle. So you're looking for the greatest common factor of both terms, and then we're gonna, instead of distributing it like I did here on step 2, we're gonna pull it out. All right. So this would be my final answer right here. Be careful when you're typing it in that you type it in correctly. It's easy to get typos, and then I'll mark it wrong. So 2 parentheses 8a plus 5. Don't forget to close parentheses. Check answer. All right, the next question talks about this idea of like terms. Like terms. So this is the word that we're talking about here. And I'm just going to grab one of these right here. I'm going to grab this one to start off with. It says 6xy minus 10xy. And a like term means that they have the same variable component. So if I look at, so each of these is a term, right? This is a term right here, and this is a term right here. So this mathematical sentence has 2 terms. And I want to look just at the variable part of that, all right? This has an xy. This means x times y. This also has an xy. So we say that they're like terms. And the reason this is important is because at some point I can eventually combine these. Right now they're in 2 piles. I can eventually put them into 1 pile. So for this question, we're just looking to see which ones have like terms. So let me show you an example of one that does not have like terms. Because this can be a little confusing at first. Look at this one right here. I'm going to rewrite this. It says 11m plus m times n. All right. So this also has 2 terms, right? Here's my first term, 11m. This is my second term, m times n. And I want to look at both of these and see, do they have the same variable component? Well, this one has an m. This one has an m times n. So they have different variable components. Even though this one does have an m in it, the m is being multiplied by the n, and that changes everything. So these have different. We can't put these in the same basket, which is where we're headed here. We can't combine these. So these have different variable terms. So what you're going to do is you're going to go through your list here. So my first one, negative 4m plus 2m. I'm just going to look at the variable part. Is the variable part the same? I have an m, I have an m. Yes, this one is the same. So I can go down to my list here and say yes, this one does have like terms. Okay. On to the next one. 5y plus 5x. Okay, this one has two terms. I think they all have two terms. I look at the variables. This one has a y, this one has an x. Those are not like terms, right? This one is talking about y's, this one is talking about x's. So I'm not going to select that one. That one does not have like terms. I'm just going to do one more here. This says t plus 7.75t. So I do have two terms here, right? Here's my first term, here's my second term. This one has a t, this one has just a t. So these do have like terms. So I would click on that one. And there's more, but just in the interest of time, I'm not going to go through them all. So again, you're looking at just the variable part. Is the variable part exactly the same? And that can get confusing when you're looking at ones like this, because they do both have an m in there, but this has an mn, and that is different than an m. It's getting really abstract. I know some students struggle with abstract, so please ask questions in class. We can do lots more examples. All right, why do we want to know about if expressions have like terms? Because if they do have like terms, we can combine them. So look at this question right here. It says negative 5m plus 3m. So the first thing we notice here is they tell us that we have like terms. And if you look at the two terms here, yeah, this one has an m and this one has an m. So then if these have the same term, then I can put them all in one pile, right? Think of it this way. If I have 3 apples, if I have a table and I'm selling fruit, and I have 3 apples on the left side of the table, and I have 2 apples on the right side of the table, well, I can take all those apples and put them in one pile, right? 3 apples and 2 apples is 5 apples. Except here, it's a more abstract, right? We're talking about a variable. So I have negative 5m's, and I'm adding 3m's. Essentially, this is just saying, hey, what's negative 5 plus 3? But we're talking about m's. So negative 5m's plus 3m's, that's going to equal negative 2m's. It's really the same math problem as negative 5 plus 3, except we're talking about m's. And what combining like terms allows us to do is take complicated mathematical expressions and simplify them, clean them up into simpler mathematical expressions. Let's be negative 2m. Got it. All right, moving right along. I know I go kind of fast in these videos, and again, that's why it's so important to ask questions in class. A student received a coupon for 11% off the total purchase price at a clothing store. Let Z be the original price. So Z is our original price. Use the expression below for the new price. And then we're going to write an equivalent expression by combining like terms. So they give us the expression they want us to use. I'll rewrite it. They say, okay, this is the original price, but we're going to subtract 11% of the original price. And remember, to find a percentage of something, I can just multiply it by the equivalent decimal. So 11% as a decimal is 0.11. If I multiply that by Z, this term right here will represent the savings, right? How much I'm saving, and then we subtract that from the original price. Well, if you look at this, Z's are kind of confusing because they look like 2's. But if you look at this expression here, I have Z minus some portion of a Z. right? So because they have like terms, I can combine these. What this is really saying is this is 1z, right? I have 1z, and I'm subtracting 0.11 z's. So what's left? Well, what's 1 minus 0.11? It'd be 0.89 z's. In other words, you're paying 89% of the original price. This portion right here, ooh, that's not what I wanted. This number right here tells you the percent of the original price that you're actually paying. And this right here represents the original price. So this kind of question can be a little confusing because you don't see this 1 here, right? I drew it in myself. But all it's asking you is if I have 1z and I take away this portion of z, what do I have left? It's like if I have 1 pizza and I eat 0.11, I eat 11% of the pizza, well, you have 89% of the pizza left. So maybe it's easier to think of it that way. All right, moving right along. Probably got time for 1 or 2 more. This one's similar to the last one. Okay, it's probably the last one I go over. They want us to factor this one. Remember, factoring is where we pull out the numbers that they have in common, right? The greatest common factor. So I'm going to rewrite this. It says 18x minus 12xy. Okay, so here we have 2 terms, and I want to factor this. So I have to look at everything they have in common. Well, let's start with the numbers. What number divides evenly into 18 and 12? Well, 18, again, I'm going to ignore 1. 18 is divisible by 2, by 3, by 6, by 9, and by 18. 12 is divisible by 2, 3, 4, 6, and 12. And so they have several numbers in common, right? 2, 3, and 6. I want to choose the biggest one. So they both have a 6. Okay, so we're going to rewrite this by factoring out a 6. But they also have something else in common. They both have an x, right? So at some point, this term and this term were both multiplied by x. So I can factor out the x as well. So now I have to ask myself, 6x times what gets me to 18x? Well, if I have 6 x's 3 times, that would get me to 18x, right? Then I have my minus sign. 6x times what gets me to 12xy? Well, think about it just from a number perspective. 6 times what gets me to 12? That'd be a 2. X times 1 gets me x right here. So we can actually ignore that. And then I still need the y. All right, so let's think about this. I want to show you, this one is definitely probably the most confusing for students because it's really abstract. I'm gonna start from this one and distribute. I'm gonna go the other direction and show you how we get from this pink one to this black one, so maybe that helps you understand both directions. If I were to take 6 x's and multiply it by 3, that means I have 3 piles of 6 x's. Again, you can think of it as apples. If I have 3 piles of 6 apples, well, I'm going to have 18 apples, right? So I'm going to have 18 x's minus, all right, 6x times 2y. 6 times 2 is 12, and then I still have to multiply by x and by y. So we end up right back where we started. I'm happy to do more of this type of problem. Again, this one can be a little more confusing because of the double variables. But basically, look at your 2 terms, and you're going to factor out everything that they have in common. In this case, they had 6's in common, and they had an x in common. And so we were able to factor those things out. All right, I'm coming up on 15 minutes. Again, this video is not supposed to teach you everything, just to help you, give you some hints and get you started. Make sure you ask lots of questions in class. See you guys soon.